Hello and welcome back to Chemistry 2. So I'm going to be basically going into a bit more depth of what I did last time. So if you'll recall, what I basically said, I defined what the atomic number was as Z. I defined that to be, that's the atomic number. So, and the atomic number has a few things. So it's the number of protons. Um, Number of protons in nucleus, and number of electrons. And these, of course, have a negative. It's equal and opposite charge that I spoke about. Coulombic charge. That's the measure of charge. Coulombic, yeah. Okay. We also look at the position of the element. Yeah. In the periodic table. Okay. Then what else did we speak about? Well, I spoke about the mass number as well, and the mass number is A. It's the sum of protons and neutrons. So they're what we're going to be looking at. Yeah. So atomic number is number of protons, mass number. So Z, number of protons, A, number of P plus N. Okay. So yeah. So that's a good way to look at it because, when we look at the number of protons, that's going to be fairly consistent. But yeah, so what we need to look at is the isotopes now. All right. So the atomic number is going to be the same, right? Yeah. Okay. So let's look at okay. So let's look at hydrogen, right? So hydrogen, yeah, is going to be the atomic number is the same, isn't it? So atomic number is 1. In all cases. Right? So, yeah. So the atomic number is Z, right? So for hydrogen, um, Z equals 1 in all cases. There's no case where that doesn't occur. All right. And obviously, we have to also mention the protons and electrons are identical in any case, in all cases again. Just to be, clear on that. All right. So if we're dealing with an isotope, right, then obviously what's happening, if we look at this, we can see the mass number A, that's going to actually change because now the neutrons are different. But like I've just mentioned, the Z is going to be the same because that's the atomic number. So the atomic number is going to stay the same, but the mass number is going to change. So what we need to do is look at. So we're looking at hydrogen. So basically, right, in any case, right, with element X, right, we're going to have the mass number is going to be at the top, atomic number at the bottom, and that way we can just refer to. So this way we can vary the mass number, but keep the atomic number the same to say, all right, we're still dealing with X, but we're dealing with this isotope, and we say this or this or this by varying the mass number. So in other words, we can say it's A, Z, and then a big X there. So yeah. All right, so we look at hydrogen then. What can we see with hydrogen? Well, what we need to do is obviously we need to look at the number of protons and number of neutrons, right? So we'll put protons here, put neutrons here. So they're going to be the rows that we're looking at. But all we need to do is think about columns. So basically there's 3 isotopes of hydrogen. So hydrogen has 3 isotopes. Okay. So we're dealing with protium, dealing with deuterium, and we're dealing with tritium. So yeah, so 1, 2, 3. Okay. So if we just go up a bit actually. So we can see what we're dealing with. So the atomic number, right, is going to be, so what we're going to do is we'll put the H here, right? Now the atomic number, like I've mentioned, is always going to be the same. It's going to be 1, because it's right at the beginning, isn't it? Now, there's also, so we have to add to get, so we have to look at how many neutrons there are, right? So basically, there's none. So yeah, so there's 1 proton. Let's make it to hydrogen, but there's no neutrons. So it doesn't need to have neutrons at all. So that's that, and that is actually wow. I don't know how I managed to do that wrong. Now that is a 1. So basically, we look at the number of protons. So there's a 1 there. Yeah, that couldn't be. Yeah, if that was 0, that would be quite the interesting thing. Because then they would have to. Yeah, yeah. But it's a basically, it's 1 proton. There's no neutrons. So take the number of protons, the atomic number at the bottom, Z. The atomic number Z is 1. So then we're going to then look for the mass number, which is going to be the number of protons plus the number of neutrons. There's 1 proton, there's 0 neutrons, so we do 1 plus 0 is 1, and so we get 1, 1, then 1, and then hydrogen. Okay, so deuterium, right, it's going to have 1, it might be easy to do it this way, it has 1 proton and 1 neutron. So again, we'll put the atomic number first, there. Now we add them up, see 1 plus 1 is 2. So it's going to be 2, 1, and hydrogen there. And tritium is, yeah, it's 1 and 2, so it's 3, 1, hydrogen. So there we go. So yeah, so that's basically how it's going to be done. So yeah. And often, actually, because the atomic number is often the same, things are not always referred to quite like this. So basically, if it's the same anyway, so let's do an example. For uranium, right? Wow, don't know whether you begin to the end. Okay, so uranium, right? It's got an atomic number of 92. That's the atomic number. So yeah, so it could actually have we can have a well, not but really. Now A, so the mass number can be 235 or 238. So yeah, well, it can be other ones as well, but these are the most famous ones. So we can write, can be written without putting, so basically it can be written as 235 U. So we don't actually need to put the atomic number there. So it's just a just convention that that's done like that. Okay. So let's just look at some more kind of basic sums that we can do with this. Now, so we look at methodology. To calculate. Okay, yeah. So the methodology to calculate composition. So what I need to do as well, we're going to go through, like I said, just going to go through some sort of simple sums for this atomic composition. But what I want to do is just make a point of an ion first. So an ion, right, is yeah. So what we can say, right, is that one, yeah, in general. So if we have one, so we have a silver ion, right, and then we do 1 plus 1 electron. That equals 1 like atom, just a regular one. So what you can see is the ion, right, is plus, and the electron is minus. So it goes up to the plus and then back down. And that's basically yeah. Yeah, yeah. There's not really much more I can say about that, really. But yeah, I mean, but obviously, ions are crucial. So I mentioned that. Now, next thing is, yeah. So an ion is basically a positively charged particle. Yeah. And it's actually how reactions occur. And there's actually something called ionization energy. But I'll be speaking about that later. So let's just look anyway. Let's just after that sojourn. So we said the number of protons is Z, right? And we've said that Z is the atomic number. So that's cool. That's going to help us define what the elements are. So we're going to find a number of neutrons. We'll do so the number of neutrons is going to be A minus Z. So we do the mass number, which is the protons plus the neutrons. So basically, so what's that saying? It's saying, that's just basically saying protons plus neutrons minus protons. That's really, I mean, that's all it's really saying. Number of neutrons. So yeah. So for instance, so for uranium, right? So the atomic number was 92 for uranium. So if we wanted to find out the, so yeah, it basically, you just do 235 minus 92. So what is that? 235 minus 100 is 135. Minus 92 is 143, or 143 or 146, I think. Yeah, looks right, doesn't it? All right. So that's basically how you would do that. You know, if you only, I mean, obviously this is saying if you only had the atomic number and the atomic number Z and the mass number A, and you were asked to find the number of neutrons, that'd be how that would be solved. Now, as I also mentioned, the atomic the mass number. It's funny because you think it's going to be the other way around, in a way, but in fact, the atomic number, right, is Z. Atomic number is Z, and then but you would think, to be honest, the atomic number would be A, but that's not the case because the atomic number is actually Z, and the atomic number, like I mentioned, is number of protons, or as I'm about to state now, is the number of electrons in a neutral atom, right? And that's also Z. So yeah, that's also the atomic number. So yeah, so the number of protons and number of electrons is equal in a neutral atom, though. So it's not without charge, without any Coulombic charge. And remember, this is a, it's like electrolytic charge. It's a very powerful charge. So yeah, considerably stronger than many other forces. It's very strong, this stuff. So yeah, so number of electrons in neutral atom. So you can also say that the number of electrons, and you just really have to think about, like, minus minus, if you subtract a minus, you're going to get a plus, and sort of stuff like this. It's, really, I mean, I've always found that quite useful. So number of electrons in a positive ion. All right. So yeah, so we've got the atomic number minus the charge on the ion. Yeah. So we subtract the charge on the ion. So yeah, so that is going to basically, most of the time, it's going to mean that the number of electrons are going to be greater. Okay. Because, the atomic number minus the charge in the ion. So let me just think about this a bit. So we've got a positive ion. We do the atomic number minus minus the charge in the ion. So let's just think about this again. And then we have a number of electrons. A negative ion. is the atomic number plus the charge on the ion. But yeah, the real thing with this is you always have to look at you know, the whole minus is plus. So let's look at this. Magnesium, right? That's element 12. So it's 12. So the atomic number is 12. So just atomic number is 12. It's in group 2 of the periodic table. Therefore, double charged ions. So we call them 2 plus. So we put the integer value before the sign. So we have magnesium 25. So okay. So for magnesium 25, and that's an isotope, of course. What we can say, right? Well, we know that its atomic number. We just put it here, right? We know its atomic number is 12. So what we can do is, as we mentioned before, if we do the mass number, which is 25, subtract the atomic number, which is 12, we can then find out the number. We can then find out the number. Sorry. If we look at the total, so the total, yeah, I'm not sure if actually the total has actually got a specified name. Yeah, it's just the isotope number, isn't it? Really? Yeah, the total. I'm not sure what the actual total, the name of the total is, but anyway. So what we can say is that the total is this. So yeah. So let's look at what we just done. See if we can get any clues from this. Because obviously I know how to do it, but I just want to see. No, yeah, it is the, yeah. The mass number is the total. Yeah, the mass number is the total. All right. So I was right the first time. Just thinking, no, I don't think there is actually anything missing. Yeah. So that would work out, wouldn't it? So we just say yeah. So if we wanted to find out the atomic the number of neutrons, we're just going to take the mass number, which is 25, minus the atomic number, which is 12. So we're going to get. So basically, we know now that there's protons is going to be 12, and we just do mass number minus atomic number to get 13 neutrons. All right. So there's that. But of course, this is actually an isotope, so it's got a charge on it, and the charge is 2 plus, right? All right. So what we need to do then is, so the charge is 2 plus. I'm probably gonna do more of these as well, actually. All right. The charge is 2 plus, right? So what we need to do is we need to take the atomic. So the atomic number. So yeah. So the atomic number Z, as we've mentioned, is 12 because that's the number of the protons as well. And it's a neutral atom. But we're not. This is not. So we've got a positive ion here. So for a positive ion, remember we said it's Z minus charge, ion charge, right? So the ion charge is 2. So then we just do 12 minus 2 equals 10, and then that's going to give us the number of electrons. is 10. Yeah, looks right. Looks right. Okay, so I think that is going to basically wrap this up. I may do a bit more